Alright guys, I want to do a video on this particular model because I've had a lot of questions about it. So I wanted to do a video on this one. So this is 1400 watts. This is the HSTNS-PD43. These are 200 volt only, so 200 to 240 volts input. And they rate these at 12 volts, 117 amps. Of course, to figure that out, you take your wattage here and divide it by your voltage, and that will tell you how much current. These are Gen 9 power supply. They are still available. Pretty cheap, I guess, considering the current, usually between $20 and $30 each. These ones are Platinum Plus rated. So let me back this out here and I'll show you just for a, this is my test unit, it's already set. So just for size reference, so this is the 800 watt. This is Gen 9 also, Platinum Plus. You can see it's the same size. Here is the 1200 that everybody's been raving about here lately, just so you can see the size difference. So 1200 watts, 1400 watts, 800 watts. This will work on 110 and 220. I would not expect, you know, a bunch of power out of this thing at 110. They only rate them at 800 watts at 110. So keep that in mind. They will work on 220, and then that's when they go up to 1200. But on 110, don't expect a boatload of power out of them. So, all right. So we're going to go through this here. First thing you need to do is verify that it works when you get this, okay? So if you look down here, pin 1 is all by itself. 2 and 3 on the top, going from left to right. They get put together, and then the 3 pins get combined. So I just put a solder blob here because I always switch my power on the AC side. I don't switch it here because if you turn this off, it's just turning off the DC output. The AC side, or the primary side of this power supply, is still on, so it produces heat and uses energy, of course. So if you just go wire a switch here and do it that way, pin 1 would be on one pin of your switch, 2 and 3 would be on the other pin of your switch, and of course that would turn it on. This is negative, this is positive. After you turn it on, green light here comes on, verifies that everything's got power. Check your voltage. These here, they do have the hole in the case. They put a little sticker over, and you pop that sticker off. There's a hole in the case, and you can adjust the voltage in these. I recommend using a ceramic screwdriver, not metal. That way, if you slip and touch something, ceramic does not conduct. Short something out. Anyways, so you verified everything's working. You disconnect your power. We're going to take the lid off here. These only have 2 screws in them. One in the top here, and this one here in the bottom. So we'll pop those out. Like I said, I've already been into this one. This is my little test unit here, as you can see. All right, so these lids, you have to slide down or push towards the connector here, and then they'll hinge off to the side. Once you get them past that little locking point there, see? Then they just pop right open. And you can take the lid off. All right, this clear plastic, try not to damage it. I'm sure it is, you know, kind of relevant to being there, or they wouldn't put it there. I just like to fold it over a little bit and then just use painter's tape, because you're only going to be in here for a couple seconds. These things are real easy to mod. Okay, so let me see if I got something to pop that up with. All right, I'll zoom in on it. There we go. Okay, so This little flap here pops open. Pretty simple. This is your voltage adjustment. This is the one that you get to through the hole in the side. You see what I mean about if you're using a metal screwdriver and you missed and touched something else, it might not be a good situation. It might kill the power supply. So, like I said, I do recommend a ceramic screwdriver. That way, if you touch anything, you know, it doesn't conduct. Ceramic. You could probably use plastic too. I know they make plastic ones that are a little bit cheaper. Just anything like that. You know, something that doesn't conduct. You don't want to short anything out. Okay, so like I said, these things are super simple to do. That's our variable for our voltage. This resistor here is for to raise our voltage. I have a 12K in here, so this will go 14.4 to 15.8 all the way up. I will zoom in on that so you can see where to place that. Okay, so there is a couple holes here. That's where a plug would go. That's not being used, obviously. So there's 5 blank spots here. So the 5th one, all the way from right of the variable, the 5th one here is ground. And then this right here goes to the trace for the variable resistor. Let me get my little pointer. So it shares this trace here with the variable resistor. It's a lot easier to solder onto this guy than it is to try to solder on that leg. So that's where I placed it. This is what was easiest for me, right here, right here. This is a Teflon wire, scrap wire that I had, and you know, you just strip it and then run the lead of the resistor through it just to insulate it so it doesn't touch anything. And then we'll move over here to the overvolt. All right, so right below that blank plug here, the second one from the variable voltage control, the second one, if you go down, there's a little SMT resistor here. You want to solder it on the bottom of that SMT resistor. Okay, this is a 4.3K, and it goes from here to ground. So this right here is your overvolt or your crowbar. Down here on these header pins, the bottom row, going from left to right, it's the 4th pin here, as you can see. So bottom row, left to right, 4th pin, 1, 2, 3, 4. Okay, or any ground. That ground's easy to get to, so that's why I went there. Like I said, this is a 4.7K. For the overvolt, it will go to 14 volts with this, and it will go up to 16.3. Don't go past 16. The DC caps are only 16 volts. So the DC filter caps are only 16 volts. Don't go past that, or they might go boom. But yeah, that's it. Super easy to do. And then you just fold over your insulator here, and these tabs go in and lock in like so. Well, this one's gonna fight me now, but normally that's what they do. They just slide right back in. Always gotta be one that fights you. There you go. All right, so that's kind of what it looks like when it's all back together. You can see the resistor over the top, and the 4.7 I just try to put so where it's not laying against something. So your lead lengths here or up top might be different, but you know, 4.3K. It's 4.3K for the overvolt. Now, if you want to run this power supply at a lower voltage, like I said, the OVP is only good down to, I think it was 14.2 or 14 volts, right around there. If you wanted to go to 13.8, then you'd probably want like a 5.1 or a 5.6K here. And then you would want a little more resistance, maybe 15K here. And then that would probably put you in that like high 12s to low 14 range. And then your overvolt would still work properly. So put our plastic cover, slide it back over. Now we got our mods done. And put our lid back on. I guess I can zoom that back out now. Fold it over, slide it down. Put your 2 screws back in, because you don't need the lid off to set these now. Like I said, these ones have the hole in the bottom here. So you can just pull that little sticker off and get right to the variable. So slide these back on. Here's our unit. Put our little voltmeter here. Hopefully there's no glare. Hook up our leads, our worn out test leads here. The alligator clips are getting pretty worn out after you do a couple hundred of these, but they're inexpensive, so I'll get another set. Okay, so we are back on it. Bang. Yeah, 1400. Wish I had something I could put back here to maybe that'll work. Probably not. Nope. Okay, just leave it like that. All right, so we want to plug in our power cord here into the unit, and then plug it into our outlet. 15.5, that's what I got it set at. Like I said, you can change that real easy. This little sticker comes off. There's a elongated hole here so that you can adjust that voltage. But the fans are nice and quiet. Our fan 1, these are 94% efficient because they're the Platinum Plus rated. Like I said, if you're building a big power supply, and it's going to be on 220 volts, 6.7 amps, so 7 amps basically. You could run 4 of these in a very small, enclosure on 220 volts, and I mean take up the footprint of probably like a 20 amp pyramid, with the transformer in it or something like that. Very small, very compact. Anyways, so lights on, we got power, so we know our crowbar circuit is working. It's metering, it's doing what it's supposed to do, because the light is on, and this light actually functions off of that circuit. So if you go to power this up, you got voltage. Let me put my clip back on here. You got voltage on your output but no green light, then your overvolt needs to be adjusted a little more or a little less resistance. A lot of these resistors are 5% or 10%. I mean, for doing stuff like this, you really shouldn't have to buy 1% tolerant resistors, so. But yeah, that's it. Real simple. Everything's on one side of the board. There's no taking screws out of the board and flipping this and doing that, and, just making a big pain in the butt for everybody. This is real simple. If you wanted variable voltage, it'd be easy to do. Literally run a wire, a small gauge wire from the variable where the 12K was, out the side of the power supply here, and then this is ground. So you'd be able to go down so much and up so much before the crowbar circuit starts kicking in. So if you get too low, it's going to turn off. If you go too high, it's going to turn off. So you usually want to set that crowbar somewhere, to where you can have a little bit of a drop in voltage without it. These clips are all worn out. Every time I move them, they change. Yeah, junk. But every time you move it, the voltage the crowbar has to kind of move with it. So, but anyways, yeah, that's it. Super light, super compact. You can fit 4 of these comfortably in a DC5 cabinet from ICA. Comfortably in there with no issues. So hopefully that helps you guys out. Like I said, this is the HSTNS-PD43. They're 200 to 220 volts or 240 volts only. 1400 watts. They are platinum plus rated and 94% efficiency. Very nice unit. I like these a lot. Also, if you want to take this tab off here, this lock, it's real easy to do to save yourself some space. When you have this top lid off, just drill out these 2 holes, these rivets, and that latch will come off. You can take the handle off here, and that will save you some space, you know. But yeah, I like these. Like I said, very, very nice, very compact, lightweight. Don't make any noise throughout the HF band for my radio guys. No noise whatsoever. It doesn't seem to matter how high you take the voltage. Some of these, once you get past like 14.7 to 15 volts, they start getting trashy on the HF bands. This one here, when we tested it, I took the variable all the way down and all the way up with the 12K resistor in it. No noise whatsoever. Checked all the HF bands. So yeah, very impressive. Like I said, these are still manufactured. This is a Gen 9's current production still. You can find them used between $20 and $30 each. For the power and the efficiency, you really can't beat that. So like I said, I hope this helps you guys, get you in the right direction. You can play with the values of the resistors and get your voltage where you want it. You know, some people might not want 15.5 or 15.8. You want 13.8. Like I said, you probably want to do like a 15K resistor up here, and for the overvolt, maybe like 5.1 or 5.6, something like that, and that'd get you in the neighborhood. So pretty simple. All right, guys, we'll see you.